Hey, welcome back to Well, That's Interesting, the surprise edition. Today is episode 194. Each nostril has its own distinct sense of smell, and tree roots may have caused mass extinctions. My friends, today is going to be one of those days where even the nose on your very own face will leave you astonished. Now, I want to begin this intro with an odd fact about this show. Believe it or not, we've never covered a study about the human nose itself. We've only brought it up as a background character while meandering down old medical oddities lane twice. Once in In-Betweenie 067, Man Grows Tooth and Nose, and In-Betweenie 035, Runny Nose, Could Be Brain Fluid. Yeah, it may be shocking to hear for some, but sometimes a nose can grow teeth. And sometimes brain fluid can leak out of your schnozzle. But even more shockingly, we covered these topics way the fuck back in 2021. I believe now is the time for the human nose to take center stage as lead character. It's long overdue. And the study we're going to dive into in the first half of the show, it will make up for that. My friends, thanks to researchers at not one but 3 establishments, we now know that both of our nasal passages respond to scents independently to help us accurately figure out where a smell is coming from or what it could be. My fragrant business goose, it looks as though the nose is a dynamic duo, not just one piece of hardware on your face. We will get into the brain-probing, scent-filled tube experiment that discovered this new nose fun fact, and which furry animal shares this same skill, what scientists called smelling in stereo. Then after the break, another shocker hiding in plain sight, but this one will make you look at trees in a whole new way. I'm just going to lay it out right now. New research reveals that some of the most devastating extinction events in our planet's history were probably the work of tree roots. You heard me. Now, for context, back in the milestone of episode 150, we covered the all-caps obliteration caused by the Chicxulub asteroid. Everyone knows it as the big old rock that wiped out the dinosaurs, but this thing did not discriminate. It actually killed off anything on land that was larger than the size of a raccoon. About 75% of terrestrial species went extinct. Now, what if I told you that tree roots annihilated 70% of all life in our oceans? Yeah, it happened hundreds of millions of years ago, and we're going to take a trip back in time to witness it all, where I shall explain how in the holy hell. In the meantime, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my flowering business goose. To begin, I'm going to ask you to imagine your beautiful head. Just your head. Come on, don't be shy. You can do it, just your head. Okay, if you don't want to imagine your own decapitated bean, fine, not a problem. Simply imagine someone else's. Preferably someone close to you. Great, wonderful. Now, I'd like you to imagine an aerial view of that noggin, as though you're looking down like a bird. Perfect. Oh, amazing haircut, by the way. Now engage your X-ray vision and crank it up to 11. We're moving past that glorious hair and scalp and taking a peek into that glorious brain of yours, or whomever you chose as your free-floating head. I want you to point right behind the eyes there. Okay, wonderful. Now move your finger just a smidge to the right. Okay, zoom in. Keep going. A little more. Okay, stop. Perfect. What we're looking at is merely 0.3 of an inch in size, or 7.4 millimeters, but boy howdy, your life wouldn't be the exciting pile of events without it. This is the piriform cortex. found within the slightly larger olfactory cortex. If it showed up on Google Maps, it would be located at the intersection of frontal and temporal lobes, quite literally in the middle of some of the most advanced organic material on Earth. And that's no mistake. According to ScienceDirect.com, the piriform cortex plays a critical role in odor discrimination and perception, synthetic processing of complex odorant mixtures, experience and state-dependent olfactory sensory gating, short-term odor habituation, and odor memory. End quote. Well, fuck. In sum, it's where signals about scent go to be officially identified before shooting on over to other parts of your brain to make even more complex decisions based on that info. If you head on over to our social media stuffs and tap on today's post, you'll find a handy-dandy diagram of your brain bits with all parts of the olfactory cortex labeled. And as you can see, it straddles both hemispheres. Put a pin in that. So, our sense of smell has helped keep us humans alive, to say the least. From being able to identify smoke to when a meal is finished cooking and everything in between, it seems like so many of our actions are based on scent. So, for neuroscientists to evolutionary biologists, the nose is a pretty big deal and extremely complicated as a mechanism. To understand how it all works, researchers have employed, but who else? The common lab rat for answers. Now, if you're a longtime listener of the show, you know we have quite a bit in common with the common lab rat. Just a few weeks ago, in episode 177, we learned that, like humans, rats possess neurons known as place cells within the hippocampus, which is central to both memory and imagination. Within the human hippocampus, the firing patterns of these place cells are remembered and stored as cognitive maps. And get this, we now know that when you recall/imagine how to get from point A to point B, that same process occurs in rats. They too have an imagination. Go and have yourself a listen to that episode. It was 177 if you haven't. It involves tiny VR equipment for rats, and it's fucking adorable. It's so cute. Now, what I mean to say though, while clearly not exactly the same, if something occurs in us, something very similar may be happening in rats, and vice versa. Back in 2006, a study dropped, one simply called Rats Smell in Stereo, and researchers who study the human nose got damn excited. Turns out, our fuzzy friends navigate towards the source of a smell by using each nostril independently. Now, what does that mean exactly? Oh, we will get to it. Put a pin in that too. Just know that since 2006, researchers have been aching to poke and prod around the human brain safely and accurately in order to see if our sense of smell functions in the same manner. The technology to do so wasn't quite there. Well, here we are. Fast forward to early 2020s. Over the years, itty-bitty devices called intracranial depth electrodes have been getting ittier and bittier, so much so they could be implanted inside regions of the human brain never before reached. Their primary function is to record brain activity of epilepsy patients and locate the neural origin of their seizures. But, again, if you're a longtime listener of this show, you know scientists not involved in epilepsy research love getting in on this brain embedding opportunity. Back in episode 161, we heard about the monumental, painstaking process of recreating a pop song using only brainwaves. Yeah, 29 epilepsy patients signed up to have these depth electrodes implanted, and a dude named Dr. Ludovic Bellier, a neuroscientist and computational researcher at the University of California, Berkeley, stepped in with an idea to play music while the surgeries happened. Long story short, those same electrodes recorded waves produced in the areas of the brain associated with music. Using AI, those waves were translated into notes, which produced the same parts of the same song. So, it is now possible to think of a song, its melody, instruments, lyrics, the whole goddamn thing, and to convert those electrical impulses into a recognizable tune for the rest of us to hear. Reading minds is a thing now. In the same fashion, but not nearly as terrifying, researchers from the University of Pennsylvania, the Barrow Neurological Institute, and Ohio State University enlisted the help of 10 epilepsy patients who already had electrodes implanted in their brains. Why? Don't worry, I've got you. Quote, despite extensive work on odor responses in the olfactory system, relatively little is known about how information from the two nostrils is integrated and differentiated in the human olfactory system. End quote. The researchers wrote in their paper titled, Odor Representations from the Two Nostrils Are Temporarily Segregated in Human Piriform Cortex. Ooh, my friends, now was the triumphant time to see if, like rats, humans smell in stereo. Let's get into it. These 10 folks had quite a busy day smelling tubes, as the experiment consisted of pumping puffs of banana, coffee, and eucalyptus aromas, as well as a control element consisting of pure air into their nostrils. But the volunteers weren't snorting chemicals willy-nilly. Turns out the fragrances were pumped into either the left, right, or both nostrils, with a photoionization detector being used to make sure molecule levels remained consistent across all trials. Then, as reported by David Neild of ScienceAlert.com, after a volunteer got a hit, they were asked, quote, to identify the smell, then state which nostril they used to detect it, left, right, or both. Meanwhile, the researchers collected data on the brain's response via the electrodes. End quote. Well, my friends, this is a pretty straightforward, simple experiment. But holy shit, the results were anything but. When the same scent was shot up only the left or right nostril, the resulting brain activity was, drumroll please, thank you in the back, similar but not identical. I'll say that again, similar but not identical. My freshly baked business goose. The researchers discovered that while each nostril can identify a distinct smell as the same, there are subtle differences in how they perceive the odor. Yeah. And I can see your face. I know what you're thinking. You're thinking, okay, that's kind of intense. My nostrils work on their own? Okay, but maybe researchers got this result because they were pumping shit into one nostril at a time, right? Great observation. I'm so glad you brought that up. The team took this into consideration too. When shooting the same scent into both nostrils at the same time, you won't believe this, the two nostrils continued to create two distinct representations with, quote, the right nostril sending signals to the olfactory cortex in the right hemisphere, while the left nostril activated the left hemisphere. The two signals were not entirely identical, suggesting that each nostril triggered a unique experience. End quote. From Benjamin Taub of IFLScience.com. Okay, so we're getting two unique experiences from one nose. Why? Why for any of this? Why do we smell in stereo like rats? Also a great question. Well, to put it simply, two sources of information are better than one. Turns out, odors were correctly identified half a second faster when both nostrils were being used. So, the single nose on our gorgeous faces is actually a good pair of friends looking out for you. Surprise. After the break, we are sticking with surprises, but definitely shifting gears. We're leaving your brain and entering a catastrophic world. Join me. 400 million years ago, when the greatest threat to ocean life was plants. Plants. Real, really. You have to hear this. Stay tuned.
Hey there, I'm Dylan Lewis, one of the hosts of Motley Fool Money. Each weekday on Motley Fool Money, we talk through the business news you need to know and the stories moving stocks on Wall Street. On weekends, we dive into the industries shaping tomorrow and host the experts, authors, and executives that understand them. Tune in for insights, a long-term perspective on investing, and of course, stock ideas. Plenty of them. To quote a listener, it pays to listen. Check us out and subscribe wherever you listen to podcasts.
There are really many reasons to listen to our podcast, Big Picture Science. It's kind of a challenge to summarize them all, Molly.
Okay, here's a reason to listen to our show, Big Picture Science, because you love to be surprised by science news. We love to be surprised by science news. So, for instance, I learned on our own show that I had been driving around with precious metals in my truck before it was stolen.
That was brought up in our show about precious metals and also rare metals, like most of the things in your catalytic converter. I was surprised to learn that we may begin naming heat waves like we do hurricanes. You know, prepare yourself for heat wave Lucifer.
I don't think I can prepare myself for that.
Look, we like surprising our listeners. We like surprising ourselves by reporting new developments in science and while asking the big picture questions about why they matter and how they will affect our lives today and in the future.
Well, we can't affect lives in the past, right?
Oh, I guess that's a point. So the podcast is called Big Picture Science, and you can hear it wherever you get your podcasts.
We are the hosts. Seth is a scientist. I'm a science journalist, and we talk to people smarter than us. We hope you'll take a listen.
And we're back. We are so back. And since the beginning of the show, I've been charging up the old time machine. We're going to need that extra juicy juice because we'll be hauling ass over to a brief but devastating time period in Earth's history. Okay, you're right. There are plenty to choose from, so I'll narrow it down and drop these number bombs on you to get this party started. My slap-happy business goose, we've just landed in what's called the Devonian period, which took place 419 to 358 million years ago. And buckle up, because that's not even the most terrifying fact. According to geologyin.com, this was one of the most turbulent times in Earth's past, as it was marked by at least 6 significant marine extinctions, including one of the 5 largest mass extinctions ever to have occurred. I will say that again. 6 significant marine extinctions, including one of the largest mass extinctions to have ever occurred, and it happened in the span of just 61 million years. That is just so much carnage in such a short period of time. Geologically and biologically speaking, plagues of fossils around the world have been found and dated back to the Devonian. And if you're asking yourself, why and how in the fuck, you're not alone. Archaeologists and earth scientists have been testing and throwing out theories for decades. But one particular theory was always left on the table, and it's a bit of a shocker. Please, everyone, ignore the world around you and pick up your phone. Head on over to our social media stuffs and tap on today's post. After swiping past all of the enjoyable diagrams of the olfactory cortex, you're going to see a picture of a slab of limestone. I'll give you a sec. Okay, it looks like something you'd see in the MoMA, right? Like an abstract sculpture. But believe it or not, that is a tangle of fossilized tree roots. Yeah, my friends. Coincidentally, it was during the Devonian that trees and land plants similar to those we know of today first evolved. They thrived and spread across the land, ironically, like wildfire. It's been whispered that these 2 separate events, the arrival of trees and plants and the staggering end of 70% of the ocean species, were actually linked. Now, you're probably asking yourself, once again, how? How in the fuck? Well, I am so glad you asked. The basis of this theory was actually inspired by what's taking place today, right in front of our very own eyes. My friends, have you ever heard of large-scale algae blooms? Now, the term algae actually encompasses a an incredibly large and genetically diverse group of organisms, but there is one type that can literally choke the life out of our aquatic amigos. My non-aquatic business goose. If you still have our social media stuffs open, please swipe past the tree fossil and you shall see a sight that may look familiar. It's a coastline, and the surface of the water in this photo is smeared with a green coating. Let's get into it. From the right wing's arch nemesis EPA.gov, quote, dead zones are areas of water... Sorry, it's true. Dead zones are areas of water bodies that were... delete. Let's try that again. Dead zones are areas of water bodies where aquatic life cannot survive because of low oxygen levels. Dead zones are generally caused by significant nutrient pollution and are primarily a problem for bays, lakes, and coastal waters since they receive excess nutrients from upstream sources. Excess nitrogen. I'm doing great. Excess nitrogen and phosphorus, put a pin in that please, cause an overgrowth of algae in a short period of time, also called algae blooms. The overgrowth of algae consumes oxygen and blocks sunlight from underwater plants. The lack of oxygen also makes it impossible for aquatic life to survive. The largest dead zone in the United States, about 6,500 square miles, is in the Gulf of Mexico and occurs every summer as a result of nutrient pollution from the Mississippi River Basin. When some types of algae blooms are large and produce chemicals or toxins, the event is called a harmful algal bloom. Harmful algal blooms can occur in lakes, reservoirs, rivers, ponds, bays, and coastal waters, and the toxins they produce can be harmful to human health and aquatic life. Harmful algal blooms, which is really hard to say, are mainly the result of a type of algae called cyanobacteria, also known as blue-green algae, end quote. Thank God that's over with. So, what in the holy hell is overfeeding this blue-green algae? We are, of course, with excess nutrients from fertilizers and other agricultural runoff. But 400 million years ago, there were certainly no humans or farms, but there was algae and new species that had access to nitrogen and phosphorus on a level never seen before. For example, Archaeopteryx, nailed it. It sounds like a dinosaur, but it's actually the first plant we know of so far to grow leaves, and it reached heights of 30 feet, and its root system dug far into the earth, into the soil where a sweet, sweet cornucopia of hidden nutrients could be harvested. It's believed as waves of these new plants and trees grew and lived, there eventually became waves of their death. With their decay came an avalanche of nutrient runoff into lakes, seas, and oceans. And then, you guessed it, this caused a blue-green algae feeding frenzy that caused a population boom, which decreased oxygen levels to the point of mass suffocation. It ended when the runoff ran out and the algae died. This cycle happened 6 times. Well, it's a working theory anyway. So how do you prove it? Enter Gabriel Filippini, Chancellor's Professor of Earth Sciences in the School of Science at Indianapolis, Matthew Smarty Pants Smart, a PhD student in his lab at the time of this study, and a kick-ass handful of colleagues in the United Kingdom. They got to thinking, if these plants and trees did suck significant amounts of nutrients like phosphorus out of the soil, and it ended up in lake beds dating back to the Devonian, this could be key. Quote, "It's not easy to peer over 370 million years into the past," Mr. Smart told news.iu.edu, but rocks have long memories, and there are still places on Earth where you can use chemistry as a microscope to unlock the mysteries of the ancient world, end quote. Well, goddamn, my friends, Mr. Smart and the gang went to town on some ancient rock samples taken from even more ancient lake beds in Greenland and northern Scotland, including Orkney, which is an archipelago at the very end of Scotland. You can't get farther north, more isolated or fucking ancient in Scotland than this place. Just for context, in human terms, Orkney has tombs with 12th century Viking carvings and has its own language based on West Norse called Orkney Norn. And it developed on the islands about 700 years ago. It's no surprise, then, its lake beds also hold some significant history. And the rocks here just solved a mystery. Quote, utilizing lake records, elevated values of the nutrient phosphorus were detected in 5 distinct locations during the height of plant evolution and expansion in the Devonian. In each case, elevated values of nutrient input were coincident with evidence of the presence of early trees in the form of fossilized spores and, in some cases, fossilized stems of the earliest deeply rooting tree, Archaeopteris. I nailed it. In 2 cases, that evidence coincided with a Devonian marine extinction event, including the most significant Devonian mass extinction, the Franzian-Famian extinction. You know the one. It's also called the Late Devonian Mass Extinction. End quote from geologyin.com. Well, shit, that was easy. No, I'm kidding. Not really. A shit ton of clickety-clack calculations had to be made. I just read the end results to you. In sum, not only did researchers confirm these waves or cycles of higher and lower levels of phosphorus, they were also able to identify wet and dry cycles based on signs of weathering or soil formation caused by root growth. Greater weathering indicated wet cycles with more roots, and less weathering indicated dry cycles with fewer roots. The team actually pinpointed that dry cycles coincided with higher levels of phosphorus in lake beds, suggesting that dead tree roots and plant roots released nutrients into the planet's water during these times. I mean, case fucking closed, Your Honor. It was trees the whole time. Surprise. Well, as to why the cycle of mass extinctions eventually subsided after 61 million years, Gabriel Filippini suggested, quote, nature has since evolved systems to balance out the impact of rotting wood. The depth of modern soil also retains more nutrients compared to the thin layer of dirt that covered the ancient earth. End quote. But, and big but, these results may serve as a warning about runoff. There might be a lesson here. I wonder what that could be. Thank you for listening, rating, subscribing, telling your friends that they have 2 other friends on their face. And that's how you should start the conversation. Tell them also about how trees just killed everything. You can also start the conversation that way. Just meander in your conversations. And a Devonian extinction-sized thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you will love the other podcasts in this family. And please, stay interesting.